Hello and welcome to our presentation video. Our topic is wheelchair activity tracking with ActiBelt. We are 3 students from the Technical University of Munich, Kathy, Jacob and me, Lukas. Together we researched activity tracking of multiple sclerosis patients. The tracking is achieved through gyrometric sensors attached to the patient itself and his wheelchair. But why is the activity tracking of MS patients relevant? Multiple sclerosis is an autoimmune disease, which is characterized, among others, with the slow decline of motoric capabilities. There is no known cure for multiple sclerosis. One focus of MS medication, therefore, is to slow down the disease's progress. Following that logic, the development of the patient's motoric capabilities is an indicator for the progress of multiple sclerosis, which for example can be used to assess the effectiveness of MS medication within clinical trials. One of the characteristics of MS patients with declining mobility is often the reliance on assistive devices like wheelchairs from a certain point on.
But how can we track the activity or mobility of a patient? The solution is ActiBelt. ActiBelt is a real-world activity monitoring device which contains multiple sensors like accelerometers and gyroscopes to track, for example, walking speed or traveled distances. It was developed, among others, by Triumph Analysis, and it is the gold standard for mobility tracking devices in clinical trials. ActiBelt can be used by attaching the measurement device with the belt to the patient, and now the sensor sits near the body center of mass, and so movements can be measured very accurately. This leads us to the question what we want to achieve. ActiBelt works great for tracking the mobility of patients if their movement is possible without assistive devices. But currently the additional tracking of, for example, wheelchairs is not covered. Therefore, our main goal is to check if the activity tracking of a wheelchair with ActiBelt is possible. To achieve our goal, we divided our task into 4 sub-questions. What are the relevant metrics we want to collect from the patient? The second one would be how we use and attach the sensor on the wheelchair. Furthermore, we want to distinguish whether the patient is moving by foot or by wheelchair just by checking the data we collected. And therefore the 4th question is if we can in the end accurately measure the wheelchair activity. So what are the relevant metrics we want to collect from the patient? The first one would be a simple on-off time of the wheelchair, so a 0 for no activity and a 1 for activity. Then we want to collect the speed of the wheelchair and the traveled distance, and from that we want to conclude the duration and the intensity of the usage.
But how do we use the sensor? We opted for utilizing the ActiBelt's gyroscope to track the rotation of the wheelchair's wheels, as that is something that can be tracked with a very high accuracy. The first obstacle we needed to overcome was actually to attach the sensor to the hub of the wheel of the wheelchair. After a few failed attempts and a few meters of duct tape later, we decided to come up with a solution that could then be actually used in the real world and would enable us to attach and remove the sensor if needed, for example for charging purposes. We then designed a holder for the sensor with modeling software and printed it with a 3D printer.
Now that we fixed the ActiBelt sensor to the wheelchair, we want to look at the next problem. If we can track whether the patient is walking by foot or using his or her wheelchair. The ActiBelt fixed to the body, more precisely the waist, of the patient collects data about the acceleration along X, Y and Z axis. From this data, we can later extract the number of steps taken, the walking speed and the time of movement activity. Now, as soon as the patient sits in the wheelchair, the movement around the body center stops, which is an indicator that the patient is either not active at all or using the wheelchair. As soon as the patient is moving around with the wheelchair, the ActiBelt fixed on the wheel collects data about its rotation and therefore the movement of the wheelchair, as can be seen in the lower graph. Consequently, This setup with two sensors makes it possible to simply distinguish between time periods where the patient is walking, moving by wheelchair, or where he or she does not do any physical activity. For the time span where the patient is actively using the wheelchair, it was then our goal to measure the wheelchair activity accurately. From the data checked by the gyroscope and the circumference of the wheel, the driving speed of the wheelchair can be calculated, as well as the mean and max speed traveled. It can then be also concluded at what times the patient is using the wheelchair. This is displayed as activity being either 0, no wheelchair usage, or 1, wheelchair usage. From this we can extract how long the patient is using his wheelchair throughout the day, displayed as time of activity. Lastly, the distance traveled with the wheelchair can be computed from this data. Throughout our test runs, we experienced a deviation around 1%, which can be seen as a highly accurate measurement. So now, all our 4 initial problems are tackled. So it's time to look ahead and see what future work can be done in this area. Firstly, a second ActiBelt could be fixed to the other side of the wheelchair to make activity tracking of turning movements in smaller areas more accurate. Secondly, and most important, what was presented here as a proof of concept would have to be taken to a higher level by collecting actual long-time data of MS patients in clinical studies. The comparison of data between patients, but especially for a patient over time, is crucial for the further insights into the topic. Research on the mobility of patients using wheelchairs is a field which in our eyes is highly under-researched. Obviously, research is done mainly where financial profitability is expected, which from a scientific perspective is not an excuse. The activity tracking of patients using assistive devices is important, and we would love to see this topic further developing and progressing in the future.